Good afternoon, everyone. Is my voice audible? Am I audible?
Good afternoon, ma'am. Yes, ma'am.
Okay, then let's start the class for today. So, in the last class, what were we discussing? What are the things we discussed in the last class?
Prefix, suffix evaluation.
Yeah, evaluation of
Balancing the cells.
yes, yeah, and balancing the parentheses also. So there are certain rules for balancing the parentheses also we have said, and we have used with the help of stats how to do the evaluation of the prefix and postfix evaluation, right? Okay, so we'll in this class we'll see another can say concept where we use stack, and that concept has been is used a lot in the data structure. Let me share the screen first.
Your voice is breaking.
Is my voice breaking?
Yes, ma'am.
Is it breaking for everyone? Is law am I
Yes, it's breaking a little bit.
okay? So let me just try to change the Wi-Fi connection once and let me know if it works. Yes, am I audible now?
Yes, ma'am.
Okay, is it clear?
Yes, ma'am.
Or is it breaking? Okay, okay then, yeah. So let me share my screen first. Is it visible? Is my screen visible?
Yes, ma'am.
Okay, okay, great. So in this class we'll see the concept of recursion. Okay, so whenever you are handling a problem, the data structure problem related to data structure, sometimes you may encounter with this recursion. Okay, the method of recursion. So the recursion is the method when you in your problem, if you find similar kind of sub problems, okay, smaller problems which are of similar kind, then you can use the idea of recursion where you take the function and you will call it. So the idea is the function is calling itself. Okay, so it is, we can say, when you are working on a problem, so you can do with the help of iterations also and also recursion. But when to use which one, that we will see. Basically iteration is when you are taking you can say you are taking a loop and you are checking till the condition gets false. You are running through the loop, whereas the recursion is just doing what, it is taking the smaller sub problems and it is working on it till one base condition, you can say, till you get to the base condition. So that is also a kind of stopping criterion for the recursion. Okay, so here same operation or same function you are performing multiple times with different inputs, and different inputs has to be, you can say, in every step you are making the problem you are trying to make the problem smaller. Okay, and you have to have a base condition, otherwise it will go to an infinite loop, right? So we'll see with examples and it will be clear. Basically what we are doing is, so you can say once you write a recursion function, it will make the code little bit easier, which whenever you are given a problem, that can be broken down into similar sub problems. So this condition has to be satisfied for using the recursion. Okay, and there are many data structures which where you can use. We can take the tree data structure, graph data structure. This we will read, we'll study in subsequent classes when I think probably in another 5 or 10 classes. Oh, we can see. And also you can use in the techniques of divide and conquer, greedy algorithm, the dynamic programming concept. In this cases also we use the recursion a lot. Okay. Now let's see what is the skeleton of it and how is it performed. So first thing is we have to have the recursive case where you are taking the function which is recurring again and again. Okay, you are calling the function again and again, and also a base case where this condition, the recurring condition will not happen. Okay, so that it will come out of the, you can say, that particular recursion call. And the program if you see, so what you are taking is you are taking a sample recursion the function, and you are giving the parameters. You are taking one condition. If the base case is satisfied, you are returning some base case value. This value you can assign based on your particular specific problems. Okay, or else you are going for the again recursion of with some modified parameter. Okay, we'll see one example for it, and I think one or two examples for it. Okay, let's see. So let's suppose what you are doing is, let's suppose this is a program where you have the main function. Inside that there are some other functions that is given. Okay, now what you are, if you see what it is doing is, so main function is calling the bar function where you are printing this I am in main. Okay, then bar function is printing the taking the do work function. It is printing I am in the bar. Okay, then do work function is taking the do more function where it is printing the do work. One second. Yeah, so this do work function in the inside the do more function is there, and you are printing the I am in do work. Then you are coming to do more function. Do more function is giving I am in do more. Okay, so actually what is happening internally is it is taking the idea of recursion. If you see, so with the help of the stack it is doing that. So here we know the stack is taking the property of LIFO, last in first out, right? So in that what you do is, so here what you are doing is you are keeping a tab of the function which you do not use right now. Okay, so as and when you are starting from the main function, it is going to the bar function. So bar function is calling, if you are calling this bar function, that means what it is straight away going here, and it is not printing this I am in the main right now, because it is directly calling the bar function. So till that time you need to have a you need to return, once you execute this bar function, then you need to return back to the main function. So that you need to keep a tab of this part. Okay, that's why what you are doing is you are pushing the main function as of now in the top of the stack. Okay, next you are calling the bar function. So bar function is calling do work function straight away coming here, and it is keeping a tab of bar function. So it will go to the top of the stack, will sit above the main function. Next, this do work function is calling the do more function. So do more function is yeah, taking for everyone or for
Yes,
It's
ma'am.
it's
My
going
side
very
also it's
slow for a minute,
very
and then it's again coming back.
okay,
Yes, ma'am.
but okay, am I audible now?
No, ma'am.
Not audible. Oh,
Ma'am, it's very faint.
Ma'am,
okay,
your
okay.
voice,
It's very faint now. You're saying?
Yes, ma'am.
Yes, ma'am, the volume of your voice
like it's
keeps going up
varying
and
a lot.
down.
Sometimes it's fine, sometimes it goes like inaudible.
Okay, but I'm like constantly keeping the mic in with, I don't know what is happening, and I have kept the volume also high. Is there any internet issue, or I'm not understanding what is wrong with this?
Now it's okay.
Is it okay now for everyone? Is it okay?
Yes, ma'am. Yes, ma'am.
Okay then. Okay. Okay then. So let me continue with that. So what where were we? We were at do more function. So when you are calling the do more function, then here there is no other function inside it, and so what is happening is it is printing the I am in do more. Okay. So after that, this thing once you have done, that means what, there is nothing else to do with this one. So it will see what is there in the stack. Okay. So it will take the top of the stack. So in the top of the stack you were in the so that is the do work. So if you will go to do work, you have executed the do more, so it will go to the next line of the code and it will print the I am in the do work. Okay. Then it will go to the next top of the stack, so it will go to back to the bar. Then you are printing the I am in the bar. Okay. Then it will take, is something else is left in the stack, so it will go to the main. Okay. Then it will pop out and it will go to the main function where you are taking. So bar function is already executed, so you are going to the next line of code where you are executing I am in the main. Internally. Okay. Is that clear?
Yes, ma'am.
Okay. Now we'll see with another example. So here, if you see, what is this function says is it is having a main function which is calling the foo function where the argument is 3. Okay. And foo function we'll see is having running taking some instructions. Okay. So we'll see how with the help of stack we'll run this. Okay. So as I said just in the previous slide, so what we are taking is we are coming to the main function, is so it is calling the foo function. So now we have 3 as our argument. So we'll see what is there inside the foo function. So it is telling if n is less than 1, then return, or else you will go to this function. Okay. So this is your base condition. So it will, so now you will go to the else part. Okay. So it will now you have foo 3 minus 1, that is 2. Okay. So here it is calling the foo function, means instead of printing the hello world, it will go directly to it will do a recursive call where now n is now 2. Okay. So n is it is uh, it will check if n is less than 1, return. So it is not less than 1, so it will go to the 2 minus 1. Okay. N is equal to now 1. Okay. So now you will go for again 1. So again less than 1, it will return, it is not less than 1, so it will go to n 1 minus 1, 0. So 0 for 0, what you will see, you will go again 1 call. So now n equal to 0. So yes, it is n equal to less than 1, so it will now return. So till then what it is doing is, so once you are starting with n equal to 3, so at first here you were here in the main function. So when you are going for the foo function, then what is happening is it is keeping a tab of the main function in the top of the stack. Now once you entered in the foo function, so when you are starting with n equal to 3 and you have come to n equal to, instead of going for the printing, it is keeping a tab of foo 3 in the top of the stack, because this code line of code has not been executed. It has
Ma'am, it's again started. Your voice is varying.
okay. I don't know what is happening. Let me just otherwise change again the.
Ma'am, I think you should change your mic.
My mic is okay because morning I had taken the class. It was completely fine. Just
I guess, ma'am, your mic wire has been shared.
the same place, same this thing I have taken the class. So that should not be an issue. Like in Monday, I don't know. Let me. There might be some internet issue from my end or from your, and I don't know who. Is it happening for everyone or is it happening for 1 or 2 person?
Everyone, ma'am.
Everyone.
Everyone.
Okay, then let me do one thing. I'll just again change back to the uh, in different Wi-Fi. Okay. Okay. Am I audible now?
Yes, ma'am.
Is it breaking?
No,
Is
ma'am.
it break? Is it fine? Okay, let me know if it you can't hear properly. Okay, so just give me 1 minute. Yeah, is my screen visible?
Yes, ma'am.
Okay, okay then, great. So we were at main function, so we have pushed the main function in the top of the stack. Then when we were at n equal to 3 until here, we have reached n equal to 2. We are not going for the next line of code, so we are keeping a tab of foo3 here at the top of the stack. Similarly, we'll go to n equal to 2. We'll keep a tab of foo2. Foo1 will keep these things in the top of the stacks. Now foo1 is in the top of the stack, and you have come to n equal to 0. So n equal to 0. So this one is now you can say you are here. So now what is happening is you will return. Where you will return? So you will see. So this thing has been, now this condition has been satisfied. So you will see is what is there in the stack. What are the things you have kept in the stack? So you will bring back the top of the stack. So now it is you can say foo1. So foo1 is, so you will come here now and you will say okay, you will print the hello world. You can say this is n equal to 1. Next you will take the next top of the stack, that is foo2. So foo2, you will come here again, you will print hello world and n equal to 2. Similarly foo3, then you will come here and hello world and n equal to 3. Then after that you have executed the foo3 part. So you will take what is there in the top of the stack. Now main would be there. So main, it will main function would be popped out, and in the main function what is there, main function foo3 is there. You have already executed the code, so you will go to the next where nothing is there. That means you will come out of the, you have run the entire program, so that's why you will stop it there. So this is the idea of recursion. Okay, we'll see one example of this where we are this is the, you can say this is the, again the skeleton of it. We'll see with one practical example, then with the help of the stack. Okay, is this clear? How do we do
Yes, ma'am.
the recursion? Okay, okay. Now let's see the factorial function. Okay, so how do we do find the factorial of a number with the recursion method? So here, as we say, factorial is what we are taking. We are taking a non-negative number, and this is the, we are denoting factorial with exclamation mark. And if you are taking the number as n, okay, and it is a product of all the positive integers till n, from 1 to n. Okay, so this is one example. Now we'll see with the same example. We'll see how do we do the recursion. So what you are doing is, let's suppose for factorial n, the function is if n equal to 0. This is the base condition, return 1, and this is the else condition. You will take return n into factorial n minus 1. So this is the recursion function. So let's suppose we are taking n equal to 5. So what we are doing is, we are taking the 5 if it is not equal to 0. So it will come here. Now it will take 5 cross, you can say factorial of n minus 1, 4, right? So this is your, as of now you do not know what is 4 factorial, so you're just keeping it, you can say you can keep it in the stack for now. So what you're doing next, so you will call this function which is having 4. So now your n is 4, so it is not equal to 0, so it won't return 0. So what will you do here? You will take n, that is 4 here, cross factorial of 3, okay, n minus 1, right? Next is what, you are at n equal to 3, so you will take 3 cross factorial of 2. Okay, you don't know now factorial of 2, so you will take the next call, the factorial of 2 is your n now, 2 cross 1 factorial. Okay, next is, now it is 1. So 1 is, so you are pushing 1, it is not equal to 0, so you will take 1 into n minus 1, so 0 factorial. Okay, so now you will push 0. So now it is, you can say the base condition is true. So if it is 0, then zero factor. So if it is 0 means n equal to 0, so you will return 1. So here you will return 1 in the 0 factorial. Now it has become 1 into 1. Okay, now what will take? It will take the top. So this will be in the top of the stack. So it first, then next, then next. So now this will be in the top of the stack. So it will go here. It will take the 1 factorial value, which you know right now, you know. So you will place it. So now 1 into 2. So it has become 2. Now you will take the next top of the stack. Then you know what is 2 factorial. So now it has become 6. So you will take the next top of the stack. This it has 3 factorial. You take 6. So you will take the 24 is the value. Then you take this, and the last the final top of the stack you take, and you place it 24. So it will become 120. Okay, so this way you do the factorial recursion. Okay, so there are many places where we use the recursion that you can try on your own also. Like you can try with running your iterations and also recursions, and you can see what is the difference and how many lines of codes you are executing. You can work on your own. Many exercises would be there. Okay, now we'll see one thing. So till now I haven't spoken about the time and space complexity, but I'm just briefing you here. So what is happening is, when you are taking the recursion, when you are taking the iterations, so what is the difference is, as we know, iterations, what we're doing, we are taking a particular data structure, whatever data structure, the physical data structure we are taking, and we are just running a loop, right? So any kind of loop you are running, and you are just checking your conditions, whatever conditions you are giving. Whereas in recursion, along with the code, what you are doing, you are creating a stack. Okay, so that is another memory. You are keeping your functions here. So this takes one extra space. So as far as space is considered, so this is iteration is more, we can say, space efficient. Similarly, here when you see the time, here also in case of recursion, what you do is you are doing the pushing, popping, these are the extra things which you are doing. So that also is not very time efficient. But when you can use this, when you find in your program the sub problems which are of similar types, where you can have a function, and if you call it like again and again, you will be able to solve the entire bigger problem. Then you can go for the recursion, when you are not bothered about the time and space efficiency also, right? So this is the idea. So when to use, so when you can say, when you find this type, your problem having this type of sub problems, which if it is able to break down into such kind of things, we'll see in the trees, and the dynamic programming will need this a lot. Okay, so in that cases you can see, okay, you can go for it. And one more thing is, you have to see whether if you are not bothered about this, the time and space constraints, then you can go for it. And also sometimes when you are writing the iterative algorithms, that might take a longer number of lines of code. So instead of that, it may be of, say, we can say the number of lines with the recursion functions would be very less. Okay, and you can see you will get a quick working solution, but it might not be an efficient one. Okay, so this is the thing where you can say where to use recursion and where to use iterations. Okay, and yeah, these are the examples where we can use the idea of recursion, and we'll see all these things in detail when we are coming to trees and sorting, then divide, conquer, dynamic programming. When we are encountering with those things, we'll see in detail how do we use recursion in that. Okay, is this clear? Yes or no?
Yes, ma'am, clear.
Okay, then yeah, in the next class I'll give you another application of it with the help of recursive algorithm. And now I'm taking a quick quiz. You can open your Moodle, and we'll have a quiz. And once we're done, you may leave the meeting for today. Just give me one moment. Yeah, are you able to see?
Yes, ma'am.
Okay, then yeah, go ahead with the quiz and
Ma'am, we can leave once you're done, right?
Yes, yes.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Yeah.
Thank you, ma'am.
Okay.
Ma'am, can you show our marks, ma'am? We are done. Hello?